Right, hello everybody. My name is Shaun. I'm going to talk about extending MYOB AccountRight through APIs and I'm going to say services. When Saul contacted me and said, you haven't given me your title yet, I was reading the YOW guide and I was reading the microservices section, so when I typed it all out, I just typed microservices automatically and I forgot. So actually this is what the title should be. And some of those things may be using microservices, but that's by the by.
Maybe they're just very big microservices.
Well, it depends, you know. Well, I did have a chat with Fred George at the time. So when do we get to milliservices, kilo services? You know, when, or do we get to femto services when we get really small, one-liners and that sort of thing? But anyway, yeah, too much drink there.
Yeah. Everything bigger than micro is blasphemy. So.
Sorry?
Everything bigger than micro is blasphemy.
There we go. That's Shaun Wilde. I'm the AccountRight API technical lead, apparently. I didn't know that at the time. Some contact details there. I've been at MYOB for about 2 years, pretty well at the start of when the AccountRight started its API project. And so a little bit more about me. This is the car my kids think I drive. So there you go. And this is what I wish I was doing most of the time. So, and it's very hard to get one of those things to line up like that. Okay. And I also do a little about open cover, so anyone knows me, I always push this thing. It's an open source code coverage profiler for .NET. It's open source, and it's got under the MIT, so it's on, see there, it's on GitHub. And it's C++ and C#, but I'll just say a bit more about it anyway. NuGet's had about 50,000 downloads. That's an old screenshot from about 6 months ago, so it's not bad for 6 months, 15,000 downloads extra. And it's also integrated into Sharp Develop. And I'm actually quite proud of it, so I like people to know about it and use it if they use .NET. And there's more, and Random Hacks of Kindness, which is what I'm involved with as well. So I like to push that as well. Anyone wants to be involved in that, just look up on meetup.com and be involved. So let's get going. First, what I'm going to talk about, give you a high-level overview of AccountRight itself. Then I'm going to cover the API itself, so an overview there, and a bit of the component layout of what it is, just so you can understand the context. And then I'm going to go through designing how we designed our API. So things through like versioning of the resources, naming them, how we go about identifying those resources. And then using the API itself through like pagination and filtering. And then how we go about supporting the API, because it's a public API, it's not just an internal API. We've got partners who use it, so we have to support that. And then how we've been using it to extend AccountRight itself. And I'm going to talk about an early microservice, and I'm going to use this in quotes. Some people may agree or disagree on what if it is a microservice or not. It was a small service, 100 lines, so it meets Fred George's meaning of a microservice, but it doesn't always work in that way. Okay. So what is AccountRight? Well, it's an accounting package. And they'll start yawning now, that's very wonderful. But it's actually more interesting than you think, sometimes working in accountancy. Okay, I'm not an accountant, I can't help very well. But the actual problems you deal with, quite interesting. And the funny thing about AccountRight, it's a fat client. So unlike a lot of stuff that's in the cloud, it's all web-based. But for legacy reasons, AccountRight is a fat client, and it talks to servers in the cloud, which I'm looking here because of this point. Yeah. But it also can talk to local installs of AccountRight, which is of your local infrastructure. And it can also talk to one's in the cloud, one hosted locally to itself, where the fat client is, and on a server. So we've got this accountancy package, and you've got a client that's got to talk to all these different environments. And it has to handle different versions. Our customers, our client, are very sort of, slow to take on the new version, even though we keep pushing it out. So we have to host multiple versions of AccountRight in the cloud, with distant schemas and resources and capabilities. And we also have to support multiple versions running in server mode and desktop mode, because especially accountancy practices will have various clients of their own who are running old versions and they haven't upgraded yet and they need to all keep in sync. So it gives us some real complex sort of how to deal with this problem domain. The API, well, as I said, it's been in development for about 2 years. It's had a team of about 4 to 8 devs in that time. It's been growing and shrinking depending on needs of the customers and the company. And we also have a client support team of 3 people, and they deal with not the partners and doing the doing that customer support, doing the talks, going out, dealing with all those partners sort of thing, and dealing with the forum requests, whatever else. We released version 1 just about as when I started, January, February 2013, and it had 12 resources. It was quite okay, so you could use it for little bits and pieces, but we realised there was problems. So we released version 2 in June, July 2013 with the equivalent of about 12 resources, and then over the time that's grown to over 80 exposed resources through the API. That's growing again quite recently. And it also has to support the desktop and cloud installations. So this API has to work in all those environments that we've talked about, and the backward compatibility. And we have obviously a regular delivery to the cloud, so we can always deliver new versions to the cloud and updates and new resources. But to the desktop, we've still got that staggered delivery when people decide to take an upgrade. And for developer partners, there's thousands of, well, that's hundreds of keys up there. I am told thousands, but I'm not too sure how many of them people just register and then never use them. But there's a lot of these. And there's over 100 plus partner integrations. Most of them are actually using the cloud. And we also use it internally. So we use it for our own internal products, for Pay Direct, on the go, which is this pay billing stuff, Smart Invoices, which is due to be released soon, dashboards, Counter, which is till like a point of sale system. So this was our battleground from before. And the API has to run, as I said, in all these places. In the cloud, it mostly runs with an OAuth security layer over the top of it. And on the various desktops, it runs just obviously with basic authentication that the people who use it gets their logins to the company file. And people who integrate with us, can use all 3 scenarios to actually work with the API. And so we have to help them work in all these different scenarios as well. And the API has to behave consistently in all those, because especially if they move company files out of the cloud into their desktop and back again, they want to get that same behavior. Oops, can't spell. We use the ASP.NET Web API, largely for legacy because we are on .NET. Most of the stack and business logic on .NET, and it doesn't seem to have to reinvent the wheel, so we're leveraging what has already been written before us. But I'm not here to talk about that. There's loads of websites talking about that. Let's get on to that. But it does give us an advantage that we can use IaaS, in Azure, we host it as a web role. And we can also self-host. So when we want to run it as an application or a service, for those other scenarios I was discussing about that were local installs. And it also makes it quite easy to run up for debugging and testing, so you can spin it up, test against it, spin it back down again without having to have the whole IaaS infrastructure. And this is largely our stack. There's nothing original in there. I think most of us have seen this sort of stack before. We've got message handlers at the top, which obviously dealing with the security and sort of logging concerns, and setting up that context of the request. Controllers, which just handle the initial part of the request. The adapters, which will deal with taking that model from of the API, that resource, and mapping it to the business logic underneath. And that's largely what we're leveraging. This area here is pretty well what most of AccountRight is. We're just trying to leverage as much of that code as we can. So I'm trying to make our stuff is a very thin veneer on the top. And also get to that database. The thing is, we also have said we have to cope with multiple versions. And we do that, obviously, by hosting these adapters at the top. And we use, this works, like what we call a bridge between the two. So what we've decided to do is, rather than make the concern about which version of AccountRight the customer is talking to, the customer only has one entry point to come into the AccountRight or into the API, and then we'll deal with the complexities of dealing with the various different domains behind the scenes. So we're making it our responsibility, not there. We're not pushing it out to them, and it's very easy sometimes to push that out to customers, and we just But no, we're not going to do that. We decided to do that ourselves. It also gives us a chance to play when we have that bridge, because then we can play around with how do we host these services, do we spin them out, you know, and so we get to play around without the customers even knowing what we're doing. So. And there's a little bit of area there is about the adapters. Now, the initial side of version 1, the adapters were very thin at the top, and they just used the business logic to do all their data to get information in and out. They sort of had a command query pattern at the top. You know, you've heard people say about CQRS, and they're trying to take the ideas from that. But we realised we weren't getting the performance we wanted, so when we switched to the next version of V2, we did the query layer, which pretty well went straight through down to the database and pulled the information out as quick as possible, wherever that data store was. But the command layer, we made sure we still used the business logic and took advantage of all the stuff that AccountRight had already done and all the hard work that had been done before. That's the important bit. When we start pushing data, pulling data is the easy bit. So, designing the API. Versioning. Now, most people have had these conversations, and what I want to talk about is the conversations we had as a team. And versioning is probably the biggest conversation we always have. And it's had every time someone spins up another API. And one is where do you put it? Now, a lot of APIs have had to stick it in the URI, as you saw there, as part of the name. Some of them stick it on the end as a query string parameter. Common convention is to stick it now as a header. You may agree or disagree with any of these. And this is my favourite one, though we haven't gone this far, is to actually do it as part of the content type. Now, I actually do like the idea of the content type because it just helps you to understand about what a resource is. And a resource isn't just, you know, if you keep how you identify a resource, if you take the version out of the identifier of the resource, that is just the resource, that's where it is. The version and the format of it is just something, you know, it's just how it's represented, it isn't what that resource is. So we've gone with putting in the header, as I've put there, and we also support the query parameter. And we did the same with the format, but we didn't do it with content type to contain all both of it. We'd have liked to, but we didn't really have the appetite to actually explain that to our customers. So it was very hard to explain that out to the clients. But as I said, it's how you represent a resource, and that, let's say, the version and the format is just that representation of a particular resource, so we try to keep the name the same. Naming. This is also a great debate. I think it depends on which platform you come from. I'm from we've used nouns and verbs. But the other one is, we all know to use nouns, don't we, for REST, all that sort of thing. And verbs totally used really for services, and very rarely do you need them. We've got a few in ours, which have got a service type name, a verb type name, but they don't really have any state. They really are calculation fields. You know, say, go and calculate this tax amount for me. You know, because we don't understand the business rules for calculating tax. So that sort of thing. So we are, we mainly use nouns as a thing. But whether to use plural or not to use plurals, we've gone for not using plurals. Other ones will say plurals. And we must put S's on the end of everything. Honestly, I can't get that excited about it. It's a bit like the tabs and spaces debate. You can have these fights all the time, and people get really upset about it. It's just being consistent. Once you've chosen one, stick with it. Your clients don't really care that much. So once you've got one, go with it, stick with it. That's what's it. I normally go with, do you pluralise your database table names? And if you do, then go with that convention. Sort of works. Identifying a resource. Again, what identifiers do you use on a resource? We initially went for using like human readable identifiers. So these are like tax codes. I mean, okay, they mean something to somebody. Didn't mean much to me when I first started. Or do you use machine generated ones? It's quite common. Integers, GUIDs. The thing is that really they should always be immutable. And we all know this from REST, they should always be immutable, mainly to help with storing and caching, you know, so they don't have to keep pulling information all the time. And even then, your customers may not understand that. I know today I was investigating an issue, and the customer kept pulling all the information he needed just to make one post, and then did it again, repeated, posted. And he just didn't understand he could actually keep all that data he pulled and then make all those posts at the end. So he was complaining about speed, and we were trying to say, well, it's not doing the wrong thing. He didn't realise he could store them and look after them, because they weren't going to change, they weren't going to go wandering off these resources, these endpoints that he was already referring to. They were there, they were stuck. And so in version 1, so we went for using human readable. This immutability thing I mentioned, yeah. The first did version 1. They didn't understand that as well as they thought they did, and not all the resources were as immutable as they thought they were. So they thought they were picking identifiers that were immutable and nobody would ever change. But the crafty people worked out ways of changing them. There's always some editor dialogue entry somewhere which, under the right conditions, would allow you to edit stuff. So that created a lot of problems for us, and didn't really help us get across about what we're trying to do about this state and storing immutability. So we went to version 2. We went for GUIDs. It's an easy win. We didn't want to go for database IDs, record IDs, integers. I'm personal hatred against doing that. I don't like exposing that. Allows people to pick and choose and try and get data they're not supposed to. So GUIDs are quite useful in that sort of way. They hide away that. It's hard for them to predict about where to find another resource. They can't just sort of mine your data. So what goes in a resource? As that we had, this is our version 1 resource that we went out with originally, and we tried to be fairly helpful to help people do references. So references to different parts were using their immutable IDs, or what we thought were immutable IDs. We got a row version, unfortunately, because we had to go for a bit of optimistic concurrency, which is not very REST-like, I do admit. But when you've got different partners all trying to change data at the same time, you really wanted to know that they knew what they were changing before they changed it and not overwriting each other's stuff. It's a concession we just have to make. But at least we did try and get some metadata linking in there and try to put a bit of self. Now, obviously this is a very, oops, back to that. We haven't gone for, I think, what you call HAL, which is a more recent approach to people putting all these links in as self. At the time, we were still learning, we were still playing around with it. And that, we sort of used it a little bit, but that came from a Ruby thing. And not a lot of the team had that background to really recognise that HAL may have been an approach to take. But when we went to version 2, we still didn't use HAL. Because what we realised is a lot of our customers were pulling resources and they now had to pull all this extra information as well. So we had all these links here to various resources, and then in order for them to actually see the name and display ID, they had to go and get that resource as well. And frankly, they wanted that information up front. So rather than forcing extra requests on our servers, we sort of said, you know what, we'll just give them that extra information up front so they can do their reports and whatever else. We have to keep making those. So it's like a compromise. And rather than stick all our links at the bottom, away and unconnected, we decided to join them together with that resource and create like a link. And so it kept all that data together. So we've gone away to try and make it easy for us and to explain it to our partners who are coming from a non-REST background, even a non-internet background sometimes. They've all been ODBC driver users beforehand. And here we are saying, right, you want to get data now, forget that ODBC driver. This is an API on the internet. So we had to try and keep all that information together. We also went for trying to keep the information in an order that we could understand, be consistent. So the UID always went at the top this time. So we controlled the order, made sure that information that we wanted to present was kept together with like information rather than just being randomly distributed on the screen. So we controlled that order of presentation. And that was very useful as well, because we also support XML. The XML guys really don't like stuff in the wrong order. So some of them even try to create schemas around your stuff, even though you tell them not to, because we may change what goes out when we extend, but they will insist on it. Oops, sorry, I've just lost this. Pagination and filtering, there's not really a lot to say on there. I thought I would say a lot more. We use OData. don't know if anyone's come across OData at all and used it. But luckily the web API comes with a packaged in. So we use OData to do a lot of our pagination and filtering. If we'd used things like Entity Framework behind the scenes, it probably would have gone straight through to the database for us, maybe even slow. But we don't. We have LLBL gen as a norm, and it and OData don't really get along. So we had to look at a lot for propagating this information down the database to make it as optimal as possible. And when it comes to filtering, OData again. This information was a lot easier to propagate down to the database with these fields. And we can make the optimization and get information back to our customers as quick as possible. So if they use the right filters and understand how to paginate, we could get information back quite quickly to them. They could just page their way through the data without overloading their systems. And there's also an order as well you can put into there, which I've put this at the end. Which again, so they can always put the records, order them right, that our server does the work and they just get the information. Supporting the API, validation, frankly you just can't have enough. One of the things we found very early on is that feedback stops phone calls. So we do our best to give them as much information as possible about when they've sent us the wrong stuff as we can. And we have 3 layers of validation. We have the first layer is when it first comes into the controllers, and we just say, is it even the right shape? Is this document even look even remotely like what we're expecting? Because not all the fields are required, some of them are optional, some, we need some pieces. After that, we even then start to look at does it make sense? So not just the right shape, but just some of the information they provided, like GUIDs and whatever else. Do they even refer to the entities behind the scenes? And so once we actually believe we've actually got that document and we've unpacked it and given it to the business layer then kicks in and has its own layers of validation, where it even says, oh no, you can't do that. So along those lines, because you're trying to modify something, or your row version is wrong, or your calculation doesn't make sense, so they've given us garbage in effect, and it's up to the business layer to pick that out. So that 3 layers of validation is what we do. And then we try and then tell the user as much as possible about where the error was. So there we're telling them what line number, ship quantity was the wrong value, or there's not enough in there. Logging. Do it. This is one of the other things as well. I think it's very easy to miss out, in the sake of expediency. There is a lot of logging you can get out of an API, and there's a lot of information you can mine when you do log, and you log a lot. And we log a lot of information, and we're using Splunk at the moment there, and we're even looking at the losing Logstash at the moment as well, because Splunk is quite expensive. But we can pull all sorts of information out of there. Here we are seeing scaling. Now, you think, oh, why can't I just go to my hosting provider and see what the scaling is? Well, that's a ProdOps team at the moment, and so they, that information is ring-fenced. We can't get anywhere near it without asking them requests all the time. So I worked out a way to log it, pull out the information. I can see my scaling now. I don't need to keep asking them those questions. I can see what response codes we've got. I can see what errors are going on, what the throughput is, and I can see how that's working with the scaling. Obviously, my scaling is not doing much else. In fact, it's dropped at the end. I even have alerts on there telling me if we get a 500 error, so we can respond to them and send messages to our customers saying you're sending us the wrong stuff. And if they're sending us lots of 400s, we can do the same. We can go to them and say, look, you just got the wrong packet, you're just not understanding. Here's the documentation. Have a look. And logging's usually good. I'll talk a bit more about that later, but as I say, logging, always do it. Documentation. We've had this discussion in the past, I think, here about documentation, but do you use generated documentation like something like Swagger or something more custom? We tried, I think we had a look at Swagger early on. The guys did when they were doing version 1, and it didn't really fit with what they were trying to do. At the time, and I think it's evolved since, but I hope it will ever go back now. Or do you go for something custom? Some auto-generated stuff based on your own models and your own rules that you're trying to go with? And they had to go at that as well. In the end, manual worked. Those client support guys I mentioned, they were all PHP guys, they had a background in that, and they didn't like any of this sort of stuff. and they wanted this fully interactive system that they could like highlight and see stuff, and it didn't matter what Swagger could do, it couldn't do that. So, and that's what they wanted. They wanted to be able to do that because they knew their customers, who they were talking to, and what information they had to give them. And even giving them sort of that Swagger information is just probably just too high level for them. And they need to give samples and all this information, even about things about database size things, which I'm not too sure why they're on there, but it seemed to keep them happy. And an SDK as well. Now we have developers like them. So if you are in a position to write an SDK, you can get SDK generation tools, and if you're using something like Swagger, it probably comes for free. We had to handcraft ours because we weren't. And ours actually came out of a hack anyway when we started it. It just grew from there, from a little hack day sort of thing. The one that we have is hosted on GitHub. It's C#, .NET, portable class library, so you can use it Windows 8, Windows Phone, all your different Windows areas. I think probably even Xbox, if for some reason someone wants to write an Xbox thing to do this. Yeah. Ruby was written by the community as a Ruby SDK, and I found out today as well there is a Java one that's just been released, and that's up on Bitbucket. So somebody else has done a Java one to that. So I think that's quite good. So we're getting some sort of traction there with the community, being able to contribute these changes and whatever else, and have these discussions about what it is they want to do. Which is quite nice. Partners and add-ons. As I said about extending through the API, well, our partners are doing our extension for us. And that's where an API, if you have an ability to expose one, and you have this extra interaction, they can do all this work. So here we've got partners with AccountRight Live and AccountRight Classic there for Budget Link. In various business sectors charging, maybe I'm in the wrong business. In various sectors as well that they work in. We have a certification program. So partners who have really understand the APIs and they work with them, we can actually help us get, we have this little certification program sort of thing. I think it's quite nice, helps them get involved and helps them build their own business as well, as their clients are our clients, and we're helping each other sort of thing. And we've even got more certified here, and we've got ones who are working with both ourselves and Essentials, or as I think people used to know it as live accounts. Essentials also has its own API, and it's very similar, not exactly the same, because we're two different accounting systems, unfortunately, and we've got different needs. So our APIs are slightly different because of those needs. But we also do it in-house, as I mentioned. We've got Pay Direct, which is offering pay-as-you-go, pay money, take money on your mobile phone, and that also integrates directly into the API. So people can take payments, and their invoices and their payments are automatically updated. And that works with Essentials as well. We've got Counter, which is a point-of-sale system, which is a MYOB product. Again, that works with both. And there was an early go after Windows 8 companion app, which allows people to look at their state of their company from like Windows 8 tablet device. So it's showing that we can actually start to pull away from that fat client that we have and start creating all these little mini interfaces and interactions with the API and how to extend what people want to see. And it's not just, we have other stuff as well in-house, such as smart invoices and billing systems, whatever else, all starting to use the API to do this sort of stuff. Now, I'm going to say how a microservice saved my sanity. Bit of a background, I suppose, on this one is we had some odd behaviour in our system, and it was very hard to track out. I know it happened like once a day, once a week. It was very odd, couldn't work it out. Wasn't big enough to be of big importance. And we just thought, well, we're in the cloud, maybe something around, the cloud doesn't always connect sometimes, things drop out, things reconnect, we'll see, we'll keep an eye on it. Put some logging in there, to try and work out what's causing it to. Then it started to get worse. As we started getting more people using the system, it started to get worse. We could work out what it is. And we set logging up in Splunk to tell us there was an issue, and it was sending us lots of emails. Then people start visiting your desk, especially those ones with the in-house integrations, because they can find you. and start sit over you and ask you what's going on. And you start to become a bit concerned. So we started playing with the scaling of the server, seeing what's going on there, see if that would help us work out the problem. And it worked for a while. And then we realised it was going up to 32 servers really quickly. And this is when I realised that obviously I didn't have visibility on the scaling and Hans had to write all that logging in to work out what was going on. Because our products guys, they saw it, but they didn't realise that would be an issue. They didn't realise that wasn't the right thing for it to be doing at this point in time. And all I can say was just wibble, because frankly we just didn't have a clue about what was going on. And you do what you normally do, you add more logging. And you keep increasing the velocity, trying to get more and more information out, more and more, and nothing helped. And I had this eureka moment. Archimedes had his bathtub. Well, I'm no Archimedes. Mine's somewhere between Stud Road and the South Kippy merge on the Parks and Traffic. That's where I have all my realisations of what the idiocy things I should have done earlier that day and realised what I've missed out or what I've forgotten to do. And it was the logging. Our logging was good. What's the one thing you don't actually track is how well is your logging working. And I realised it was the logging, but I didn't know why, so I had to try and create an idea and get an understanding of what was going on. I thought I'd explain that first. We were logging to Splunk, as I mentioned, and Splunk Storm, and it's been running for 12 months beforehand. So when something's been running for that long, you sort of discount it as being the problem child, sort of thing. So what did we do? Well, we had to investigate what was going on, and I've sort of a little diagram about what's going on. So a lot of messages coming across, and the system could cope. A few more messages, the system could cope. Started to clog up. That's when we got the occasional dropout. And then they started to back up, and that's when it started to fall over. And we've all seen this problem. We all know what to do here, don't we? We stick in a buffer. It's an obvious thing, right? And this is where our little first microservice first kicked in on the API. It's an obvious problem. We've seen it. We know what to do. Just chucked all our messages onto the bus. Let the bus take the load, and we take them off the bus. A couple little servers, because it's Azure and it doesn't like them if you don't have two at the time. And that sends on to Splunk. Actually, it's actually another. I say Splunk there because there's actually a whole service of logging behind the scenes of queues and whatever else to make it through to our logging servers behind the scenes that go through Amazon. So we've got a centralised logging in place. But that was the idea, and that just saved a lot of hassle. Our problems went away just by a simple queue and another little microservice. And that little fella here is only just 100 lines of code. And most of that was actually done in just a quick spike of half a day to actually realise that it would work. It took the best part of 2 weeks to get it into production because obviously we don't have that direct interaction, but at least we had proof that we could do it. And now I can get that service into production because we have this approach within half a day now if I have a change, which after a couple of point releases never had to do since. So conclusion, we got our servers down to obviously 4 again, which was nice, and I think we'll probably reduce that, plus 2 small layers, and reduce costs. I mean, 32 servers down to 4 is a lot nicer, especially when you're in the cloud and you're paying those costs. We still have the odd SQL related issues, but they're not logging related. We've got retries around all that sort of thing now, but at least now we can actually see wood for the trees, or trees for the wood, whatever we call it. See what's going on. And we get a reduction in emails and reduction in visits, which means I can get on and do more work. So I'm not too busy sort of fending people off. So there you go. Questions? May not be the one with the thought. Okay.
So you're supporting a JSON protocol and an XML protocol.
Yeah.
I've got 2 questions around that.
Yeah.
What do people prefer? And secondly, do you use anything like JSON schema or any of those kinds of techniques?
First one, I think it depends on the background of the person doing the work. If they're using the SDKs, they don't really care because it's handled before them, and they tend to all use JSON. Yeah. So I'd say JSON is a predominant one. We have XML. We have to carry on supporting it because we have some big partner integrations who are using XML. So we can't drop it. We'd love to drop it. And no, we're not using JSON schema.
As far as the logging is concerned, are you logging each line item right to the queue?
Initially, when I started to look in the logging component and see what was going on behind the scenes there, it was logging one at a time. Now, obviously with this batching and whatever else, we're batching in big chunks to the queue. And this whole problem is that we just, if you don't know there's a problem, you don't know to look at it. When things have just been ticking along quite happily, they're just sending the messages across and quite happily just making it across the way. Once you start to look at it and realise, oh my god, how come we've left this untouched for so long? We ended up batching. So the stuff batches. I think it batches up to 32 or waits a second, whichever comes first. Yeah. And then it chucks those up onto the queue in batches. And then on the other side, I've got two servers on the other side. But they're running thread pools, so they're running about 8 threads at the same time. That's one of the advantages of being on .NET. You can spin up all these threads and they can all run in parallel quite nicely. And they just pull as much data off as they can and chuck it over to Splunk in batches as well. But it's one of those things, like I said, until you start looking at it, you don't realise just what the problem is until you go, oh, yeah, that's a bit daft.
So was that the Splunk forwarder falling over and killing the whole node? Or what
No, it was the Splunk client at the other side. So because it was just sending one message at a time, once you start logging, hundreds of messages start coming through per second on occasions, not always, but on occasions. It couldn't get all those messages across in time, to pull the sockets involved, not leaving enough sockets for the rest of the system to do what it needs to, which is talk to a database, do its job. So the logging was actually eating up all the resources and not letting the service do what it's supposed to do. But as I said, it's one of those things that only were happening peaks on occasions, and then as the system got more busy, you start to realise it just wasn't what you expected. Luckily, we didn't lose too much. There was odd intermittence up and people were concerned, but most of the time, most people just tried again, and whatever they wanted, they got. So it wasn't as disastrous as it could have been. We didn't get any data corruption or anything like that, but it wasn't ideal. Yeah.
So was that when you said you set the server to auto scale?
Yeah.
So I don't know much about the Windows environment, but so it was detecting that there was a large thread take up and therefore it was auto scaling.
The Azure auto scaling is not as great as we'd like it to be.
Right.
We've only got a couple of parameters you can play with, like memory and CPU usage and things like that. To do that sort of thing, we'd have to do some manual auto scaling, if that makes sense. We'd have to write our own processes around all of that. But you did spot that, it just sort of, the levels that the guys set would just cause it to scale up when obviously it got busy.
Yep.
So it was responding to busy, which happened to be when it needed the scale. Yeah. The thing is with Azure, the auto scaling is not that quick as well. So it's one of those things. It's not that quick. But I don't know. Yeah, it's not that quick. So you have to sort of preempt as well. So you always have to be on the side of caution. So you went up quite quickly, but you came down really slowly. And that's for the cost, because it could never really get down to what it needed to be. Yeah, it's not ideal. Yeah, if you can avoid auto scaling, it's brilliant. Or whatever, you can scale it all from that bit. We did have a try to look at the logs to work out what was going on, see where we could auto scale based on load and try and predict the load. The API itself, our API, because we've got people all around the world, we've got integrations that are running out of the US and whatever else, and so we get constant traffic. So whereas if you look at AccountRight, which is the desktop client, you see this nice peak through the day as people get up and start using it and go to bed again. So you see these nice little waves going on. The API is sort of just a constant noise, and you see little wibbles throughout the day, but nothing that you could really say, oh yeah, we can auto scale based on that. It's just not predictive. So we just try to set above and just stick it there. Yep.
So with the integration with the in-house teams, you've mandated everyone to use the API, right? No one's just like sneaking in and looking at the database or anything like that?
The in-house teams can't get anywhere near the databases. I can't get anywhere near the databases. The databases are all locked down and secure and whatever else, and literally the guys who can see anything that's going on there is the product guys, so they can't get anywhere near them themselves. So yeah, if you're going to do an integration with AccountRight itself, you either have to be in AccountRight into that business layer stack, or you have to come and use through the API. Yeah, so yeah, it is pretty well mandated, it has to come through.
So was this like an Amazon-style MYOB saying everyone needs to use APIs, or is this just something your team went in and like, we're going to expose everything to API?
No, they've had people pushing this within MYOB. So they put APIs over essentials. They've got APIs internal for other products. For talking to the CMS system and authentication systems, and obviously Essentials has its own, and Cashbook has its own, and EXO has its API as well, which are all on the models. So it's all public APIs that we expose. Our push is to try and eat your own dog food, as they say. So use our own APIs as well as obviously let other people use them. It's very easy just to point out an API and say, there you go, customers, use this wonderful thing we've created for you, but we're going to go and use these back doors. We actually use our own stuff, and so we feel it, what they feel, and so that, I think that forces us to make some optimizations as well. So when I mentioned earlier on when I had the stack and that the queries going back down to the database rather than the business logic, we did notice early on that we had some queries taking some really long time. They just didn't make sense. And then when you looked at it further, the query to the database wasn't taking the problem, it's the ORM layer spending its time building up all these objects and populating them with one or two values and then throwing them all away again, which it didn't need to do. So we actually then optimised these stacks, and things that were taking 30, 40 seconds, which is horrible, we're getting down to 2 or 3 seconds. Still not ideal. But we're then looking, now we've got this pattern that we can break stuff out. We are making moves towards actually having eventual consistency and things like that. And we've done that in a hack day as well, played around with those ideas. But on the desktops, it's very hard to stick the whole cloud integration on someone's desktop, with a document database and all these messaging buses and whatever else. It's probably not going to happen. So they'll probably use the old way of doing it on those desktop clients. But in the cloud, we've got the advantage of being able to do what we like in there and really take advantage of being in the cloud.
Just think Docker.
Yeah, which will be on Windows soon. Awesome, yay. Well, I think there's one called Spoon for Windows, which is quite good. I've heard good news about it.
Your API versioning, have you found you've gone through many major version bumps?
No, we've only really gone to second version. Okay. The move from version 1 to version 2 was, shall we say, hard and difficult for people who'd already done integrations. We're still supporting version 1 even now, even though we want to delete it. I'd love to delete all that code, but it can't. And so, in order to do the versioning, we don't actually do versioning anymore. We just try to deal with it through extension. So, and that becomes quite difficult when if somebody thinks they're talking to various versions of AccountRight, you may have a resource which has been around since early on, but you want to extend it later on, so you need to support the extension in a later version, but not let them do that in the earlier version. So you have to deal with all that at the high level.
So you encourage your API, but they're external, so they're a little bit harder to control what they do, but you sort of encourage the loose coupling to the schema so that you can sort of put new stuff in there and hopefully not affect them, or is there a playground that they can play with to test new versions?
We have sandboxes, sandbox files that we put there that they can integrate with. We don't, normally they get to see a new release when it's made, when we make it public and it goes out and we make a new version of AccountRight. So they can play with those sandbox files and work out whether they'll work with those with the new version before their customers upgrade, and they can control that. In-house, we also have our own SIT environments and things like that for our own internal products to be ahead of the game. That's just the way it is.
So will you? Oh, sorry.
Are you purely versioning the contract between different versions, or do you actually have different rules? Like, have you changed your business logic, I guess, as well, between versions?
We try not to. If there's a bug, and that business logic is part of the bug, then it's going to change. But it's fair, I mean, AccountRight's been around for a long time now, so before we even started the process, a lot of the issues have been found, and a lot of those business rules have actually been addressed. It's not perfect, it's still found the odd issue, but the actual API itself doesn't really come involved with that sort of thing. If it's the problem that changes later on, it's normally the business role below us that see that. We normally just try to make sure we prepare the object as we go down.
Yeah, so mine was related actually. So do you do any non-breaking changes within those versions?
Not that I recall. We have done so well. I think we got away. We're so glad to have got away with it.
Yeah.
I always keep. I know there are issues. There are things that I'd like to change. If I ever say version 3, I can see the product owners get a slight twitch in their eye because they don't want to go through that again. And of course, we don't want to rewrite 80 odd resources in version 3. We might do 1 or 2 resources in version 3 and slowly migrate them through. But again, there's no real need for it at the moment. We haven't had to go through that. Close, but not yet.
Have you, do you treat your internal API users any differently? I.e., do you have automated tests that contract style tests that you set up between those to sort of validate their things, or are they just say, no, you've got to use the playground like everyone else, or the sandbox like
They created the playground. So it was their playground that they created. We do have lots of unit and integration tests, you'd expect. We have a whole lot of BDD tests that we use the SDK for as one of the first phases. And that SDK is like our contract testing. And I've actually, using Pac.net, I've started using that in the contract, in the SDK to test that the SDK behaves. Haven't got to the point of actually taking those out and pushing them against the API itself yet. That's the next stage. But it allows me to actually test that SDK without actually having to push it against the server. So the test is doing what I expect as an SDK, and all its behaviours and responses and how it deals with things. So.
One interesting thing that I've been thinking, because we were looking at exposing some APIs, we have already exposed APIs to partners, and in the dev communities, Pact is getting some sort of traction around contract testing. It'd be cool to expose your services with a Pact interface that they could throw their Pact files at to see whether they would still actually pass test. Is that sort of a testing contract?
Yeah. I mean, we're quite new to Pact and Pact.net. Only come across it the past couple of months. As I've tinkered with it, and other people within the company started